So in part 2, we're going to talk about radicals. We're going to talk about some radical equations, kind of extend where we left off yesterday. First off, when you look at an example like this, you always want to kind of check what type of radical do we have. So if you'll notice right here, it's not showing. Remember, when it's not showing, you technically have an index of 2. So you have an even function. Okay? So we can actually rewrite this as 5 times 2x to the third to the 1/2 power. Now it's really important to remember if your fraction has an even denominator or not. That's what determines whether or not we have a something that looks like a square root or something that looks like a cube root. So without ever testing any points or anything, we know that the general idea of this function is it looks like that. Now the 3 inside on the x, what the 3 does is the 3 takes and it kind of lifts it up higher. So it doesn't quite look exactly like a square root, but it has the essence of what a square root looks like. And if you were to put this into some type of graphing calculator, see how it is lifted higher than your average square root. So let's go ahead and answer all the questions about it. Our domain is everything higher than and including 0. Our range is the same from 0 to infinity. So for intercepts, remember you're asking yourself, where does it hit the x and y axis? It has both an x and a y intercept at the point 0, 0. As far as the end behavior, we really only have a right end. So as x goes to infinity, our y also goes to a height of infinity. For continuity, just go back and look at your domain. Most of these functions will be continuous along their domain, so it's continuous from 0 to infinity. The only thing different, sometimes they don't always include that 0 in the continuity. And then let's ask ourselves, is this function increasing or decreasing? Well, if we had our little math bug walking to the right, you would see that he is clearly going uphill. So it is increasing from 0 to infinity. Now don't include that 0 point, because in that 0 point we have the fact that it's not really increasing at that 0 point. It's our starting point. It's our switchover point. So you usually don't include those. So by identifying what family it's in, we can take a look at what's happening to the function. Let's look at another one. So for example, 5b, we can clearly see that this is an odd radical. Our odd radicals look like our cube root. So they not only have that swoosh in the first quadrant, but they also have a swoosh in the third quadrant. Now let's look for a minute what we know. The 1/2 is just going to change the height a little bit. The 3x minus 4 is going to move it left or right. The 3 is going to kind of change how it's squished a little bit to the left or right. And the 4 is going to move it around. So if we really wanted to graph this, just take whatever's in the radical, set it equal to 0, solve it for x, and let's discover how it's been changed. So instead of it being here, what the 4/3 does is it tells us that it has moved over to the right 4/3. So it still looks like a cube root that has been shifted. So here's our first one where there's a shift kind of in its center. So let's go ahead and let's go down the list of everything. So the domain is all real numbers. There's nothing that's going to screw up a third root or a fifth root. We can plug in positives, we can plug in negatives, we can have a zero. The same thing is true about the range. This will eventually get as high as we want and as low as we want, and all real numbers would eventually be included. Now the intercepts are a little weird. The x-intercept we just found was 4/3. So setting that center equal to 0, that stuff that's inside the square root, the cubed root, the whatever, equal to 0 will always help you find your x-intercept. Our y-intercept, remember, we have to plug in 0. So we get 1/2 the fifth root of -4. Now, that's the exact answer. If you were to graph it, what you're looking for here is we are looking for that point right there. Like, where am I hitting the y-axis? Well, the y-intercept, if you wanted an actual point, when you plug in 0, you get approximately 0.66. Now, that's an approximation because -4 is not a perfect fifth root, so, it's an approximation. So here we have to actually remember our rules. So when you look for the x-intercept, you set it equal to 0. That's what we did in green. When you look for the y-intercept, that's the last thing you see here on the left here. You're going to plug 0 in. You're going to find what y value you're going to hit the y-axis when you plug 0 in. Here you would have to use a calculator to guesstimate approximately where that value is. So that is your y-intercept. Next thing they asked for was end behavior. You can tell these ends are not horizontal. They are eventually rising higher and higher and lower. So as my x goes to the left for negative infinity, my y is going down to negative infinity. As my x goes to positive infinity, my y is going up to positive infinity. So there's your end behavior. And then the last thing is where is this function increasing or decreasing? If our little math bug walked across this graph to the right, the math bug is always going uphill. So it is increasing from an x value of negative infinity to an x value of positive infinity. The y's are always increasing. The height is always increasing as we walk across this graph. Now, one of the weirdest parts of this was finding these intercepts. So let's do another example and let's practice finding the intercepts. So here's an example of an equation where they've asked us to find the intercepts. So the easiest one to do is the y-intercept. The y-intercept, we're going to let x equal 0. So it's great because we can just plug in 0. So we get the negative cubed root of -4 when you plug in 0, because the x squared would go away and you get 0 minus 4, which is -4. The negative would come out in front, making it a positive. So the exact answer is 0 cubed root of 4. If you were to graph this, that's approximately 1.56. So that's where we hit the y-axis. So that is our y-intercept. Now the harder one to me to do is the x-intercept. Now remember, to do the x-intercept, we're going to let the function equal 0. So we're going to set the entire function equal to 0, and then we're going to have to remember our rules of algebra when it comes to solving it. So let's do that. So we take the equation and we set it equal to 0. Now the first thing we can do rather quickly is to divide both sides by -1. So you can get rid of that negative on the outside real fast by dividing by -1. Next, we really need to get rid of that cube, or that cubed root, I'm sorry. And we do that by using the reciprocal power, or a third power will get rid of that cubed root, just like a square will get rid of a square root. A 5 power will get rid of a fifth root. And so then the radical and the power cancel out on the left side, leaving us 8x squared minus 4 equals 0. Now, one thing we can do, I would probably factor this, but since it's only one x squared term, we can just kind of get it by itself. Let's move the 4 to the other side. Let's divide off the 8. So we actually get 1/2. Now we got to get rid of the squared. And please remember the rule from algebra that if you square root, that you need a plus or minus in front of whatever you're square rooting. So x would be plus or minus the square root of 1/2. Now, it is customary to not leave radicals in a denominator, and technically would have this, because that's technically plus or minus the square root of 1 over the square root of 2, which is plus or minus 1 over radical 2. So we don't want to leave that square root of 2 down in the bottom. We would technically want to rationalize it. So we would want to multiply by the matching radical on top and bottom. And so we get x equals plus or minus the square root of 2 over 2. So our x-intercepts are actually 2 points. 0, positive square root of 2 over 2. 0, negative square root of 2 over 2. And if you were to graph those, you would need the decimal value of the square root of 2 over 2, which is about 0.7. So if you were to graph it, oh, sorry, those are x's. I have them switched around. Let's fix that. So square root of 2 over 2 is 0. Negative square root of 2 over 2 is 0. Sorry about that. There you go. So if you were to graph that, that would be the point 0.7, comma 0, and negative 0.7, comma 0. So those would be your points where you hit the x-axis. So now we've kind of explored radicals as far as their graphs go, their intercepts, their continuity, their domain range, all that stuff. Now let's take a look at some equations containing radicals. Now the equations, you should have really learned most of that in Algebra 2, I would assume. So hopefully this last part of the lesson would be hopefully a review of some stuff from last year, or from whenever you took Algebra 2. So here we want to solve for the x value that would make this true. Now, if you have a radical in the equation that contains one of your x's, the first thing you want to do is get that radical completely by itself. So the problem here is this 3. So let's move that 3 to the other side of the equation by adding 3 to the other side. So I know that 2x plus 3 equals the square root of 28x plus 29. Now in the last equation, we used a cube to get rid of a cube root. So now we're going to need to use a square to get rid of a square root. To do that, please surround the entire, both sides, in parentheses, and then you're going to square both sides. Now the thing I want you to remember from Algebra 2 is that when we square this left side, that we actually need to FOIL it out, or we need to distribute. Otherwise, it won't work. When you distribute that out, you get 4x squared plus 12x plus 9. And then the right side, the radical and the square cancel each other out, leaving us 28x plus 29. Now, this is a quadratic. Our highest power is a 2. So when solving it, we want to get everything to one side. We want to get it equal to 0. So let's move the 28x and the 29 over by subtracting 28x from both sides and subtracting 29 from both sides. That will leave the right side equal to 0. And wherever you can get your squared term to be positive is where you kind of want to leave it. So that's why I put everything to the left. And so we get 4x squared minus 16x minus 20. Now, if you like the quadratic formula, you can instantly use the quadratic formula at this point. You remember the quadratic formula is negative b plus or minus the square root of b squared minus 4ac all over 2a. So you could use the quadratic formula at this point. So the a value is 4, the b value is negative 16, the c value is negative 20. I think the quadratic formula is not necessarily the quickest route, the route you want to jump to first. What I would first look for, is there a way to factor this? Well, there is a 4 that they're all divisible by, so take it out. Because it's an equation, you can technically divide it out. It doesn't matter. You can just divide by 4. But you could factor it as well. Now, what's inside the parentheses are factorable quantities, so let's factor that some more. So you just have to remember your rules of factoring from Algebra 2. And so you're looking at how can I get two numbers that will multiply to give me negative 5 that will have a sum of negative 4. And that would be negative 5 and positive 1. Now, you set all your factors equal to 0. Now, here's why the 4 didn't matter. 4 will never equal 0, so you don't need it. You could just divide it out. But x minus 5 might equal 0, and x plus 1 might equal 0, and then you solve each one individually. We're not done, unfortunately. The problem is our original index was even. If it's a square root of 4th root or a 6th root and 8th root, if it is a radical that has an even index on it, you have to check them, because what could happen is a negative could disappear in the squaring process or the fourthing process or whatever power you're going to take it to, that technically when you plug it back in makes it not work. So you've got to check them. And it's just a thing. You have to do it if it is an even index. If you plug in a 5, so now I'm just checking the 5, you get 10 equals 13 minus 3, which is true. So x equals 5 works. So you can check it in your head, you can check it on paper, you can check it however you want, but you need to check it. Now let's plug negative 1 into the equation. You get negative 2 equals 1 minus 3. That one also checks out. Now sometimes you'll have both check out just fine. Sometimes you'll have one that works and one that doesn't, and sometimes nothing will work. So, please, for these, always take just a second, plug the value back into the original equation. Don't plug it back into any of your other versions. Plug it back into the very original one and make sure it works. Let's do another one like this. So here we have a radical equation. So first step is to isolate the radical, but take a second to see what kind of radical it is. It is a third root. Because it's a third root, we don't have to worry necessarily that things are going to not work. Because positives works, negatives work, whatever we get is going to work. So let's just get the radical by itself. So let's take and isolate that radical, and we need to move the 8. So that's always your first step. So we get 4 equals the cubed root of x minus 2 squared. Now the first thing we're going to do is get rid of the radical. We do that by cubing both sides since it is a cubed root. 4 cubed is just 64. The cube root and the cube cancel each other out, so that's x minus 2 squared. Now we need to get rid of the square. To get rid of the square, we inflict a square root. When we inflict a square root, on the number side, please remember the plus or minus in front. Got to remember that plus or minus. So the square root of 64 is 8. We've got plus or minus 8 on the left side. And we've got x minus 2 on the right side. Now how do you solve it from here? Well, you want to move that 2. It's going to become a positive, and it's going to sit right in front of the plus or minus. So then it will become a kind of a mathematical statement. So you're going to have 2 plus or minus 8 equals x. So then actually do those two statements. 2 plus 8 is 10. 2 minus 8 is negative 6. You can check them back in the original. If you check 10, you get 4 plus 8 equals 12. It works. If you check negative 6, you get 12 equals 4 plus 8 again. They work. So it's really essential that you always check them for even index. Odd indexes will work just fine. Just 2 more examples. Let's take a look at this one. Now, the problem with this type of example is that we have 2 separated radicals. But we've got that 1 that's just that plus 1 that's floating out there. So it becomes probably one of the most difficult of the problems that you're going to see. So you're going to make sure that one of the radicals is by itself, like this one is. That square root of x plus 1 is by itself. You're going to isolate that one. It is, so that you can square both sides. But that's where the problem occurs. You're going to square the left side, and you're going to square the right side. When you square the right side, there's an issue. Think about if you wrote 2 of those, like we're going to. If you wrote 2 of those, there are 2 terms. That makes us have to use the rules of distribution or FOILing. We have to distribute. So it does make it yucky on the right side. Now the left side's nice. It's just x plus 1. So by isolating at least one of them, one of your square roots will go away and one of your square roots won't. Now look what's left on the left side when we distribute. We get 1 plus radical square root of 2 minus x, or radical 2x minus 12. And then we get another radical 2x minus 12. So we've got 2 of those. And then when we multiply the radicals by themselves, we just get what's inside. You'll notice that we got rid of most of the problems, but we haven't gotten rid of that radical that's in our denominator, or in the middle there, I'm sorry. So now we want to isolate that term. So let's move everything to the other side except for that radical, because now we need to isolate it and try it one more time. So I need to move the 1. I need to add a 12. I need to move the 2x. I need everything that is not that radical go to the other side. When I do that, I am left with 12 minus x equals 2 times the radical of 2x minus 12. So now it's like the last problem that we had, or the first step, or the first problem we have. We still have a radical. It's by itself. So now we have to square both sides again. Here's where people can mess up. When we square this left side, we're going to have to distribute. When we square the right side, don't forget about that 2 sitting in front. It's going to get squared. So the left side is going to be 12 minus x times 12 minus x. The right side is going to be 4, because we have to square that 2, times the radical inside's 2x minus 12. And put that 2x minus 12 in parentheses, so you remember to distribute that 4 in. So let's use all our rules of distribution. So when we distribute everything on the left side, we get 144 minus 24x plus x squared. That's what we get after we FOIL everything. Distribute everything. And now we're going to distribute the 4 on the right side. We get 8x minus 48. You might notice that we have at this point a quadratic equation, meaning we've got a squared as our highest power. So let's get it equal to 0 on the right side by subtracting 8x and adding 48. So we're just moving everything to the left side so we have the right side equal to 0. We get x squared minus 32x plus 192 equals 0. If you like the quadratic formula, you could use the quadratic formula at this time. It would solve it. I try to go and factor it every time because it's usually a little quicker. So I'm looking for a factor pair that will multiply to give us 192 and add up to 32. So I just start taking the number 192 and breaking it apart. So like I know it's 96 times 2. Those don't add up to 32. It's 48 times 4. Those don't add up to 32. But if you go one more time, it's 24 times 8. Well, 24 and 8 add up to 32. So that's the one we want. This is the one we want. So it's going to be x minus 8 and x minus 24. Again, you can check it. 24 times 8 is 192. Negative 8 plus negative 24 makes the negative 32 in the center. So it's factored. Once it's factored, we just set each one equal to 0. And we solve. But look at our original problem. Our original problem was a square root. That means we have to take a second to check it. Because if you check it, maybe it'll work, maybe it won't. Let's start with 8. If you plug 8 in, you get the square root of 9 equals 1 plus the square root of 4. That's a true statement. So 8 works because you get 3 on the left side. Wait a second. No, it doesn't work. Let's see. 9, that's 9, that's 3. And then 1 plus, yeah, it is 3. I'm sorry. Okay, 8 works. Now let's try 24. If you try 24, you get the square root of 25 equals 1 plus 48 minus 12. That's the square root of 36. That is 5 equals 1 plus 6. That is not true. So just make, cross out 24 somehow. I like to just cross out the equals to sign, meaning, hey, that doesn't work anymore. So 24 doesn't work. So that will happen sometimes when you have radical equations. So, always take that last minute to check. And then we just have one more example. So let's look at this one. Now, it is a multiple choice question. If I were doing this multiple choice question, I'd plug in, I see 11 almost everywhere. I'd plug in 11. I'd plug in negative 11. I'd plug in 0. I'd plug in, I'd plug stuff in. Okay? We're going to pretend that that's not there. And we're going to actually do it and see what happens. So, if you look, we have a radical in the equation. You can move the 6 over, get that radical by itself. And then we're going to use the techniques we've seen so far to solve. So when we do it, we have to square both sides. When you square the left side, you want to actually FOIL it. You get 4x squared minus 24x plus 36. And then on the right side, the square root goes away, so you get 20x plus 36. So that's what you get when you first go ahead, move the 6, and then square both sides. So let's move these to the other side so that we can get it equal to 0. So we're going to subtract 20x from both sides. We're going to subtract the 36 from both sides, which makes our life a lot easier when it comes to solving it, because it's just 4x squared minus 44x equals 0. What's really nice is that factors very nicely, because we can factor out a 4 and an x. And when we divide everything by 4 and by x, we get x minus 11. So this one says that x is 0. This one says that x is 11. Now remember, this is a square root. So we know right now it can't be a or b. So it's either c or d. So what's the one that's causing an issue? Well, the one that's causing an issue is 0. We know 11 must work. If you plug in 11, you get 22 equals 6 plus the square root of 222. Let's see. 11 times 20 is 220 and 36, 256. Which is 16, so that one works. Okay, so 11 works. Let's try 0. We get 0 equals 6 plus the square root of 36, which isn't true. So the answer would be C. Okay, now let's look real quick at what the assignment is. Please make sure that yours has crossed out what I crossed out. So I crossed out 8, 14, 46, and 52. Okay? And then this assignment is not due until the end of class on Monday. So it's due at the end of the next class.